So, today's a pretty short one, or this lecture is a pretty short one. What we're going to do is we're going to talk about formula masses. So, remember when I talked about the average mass of an atom? So, if we have a chlorine atom, the average mass is 35.45 AMU. Remember, this isn't the mass of any single individual chlorine atom, but it's the mass of it's the average mass. So if I had millions of chlorine atoms, then this would be the average mass per chlorine atom. So in other words, if I took this mass times the number of chlorine atoms I have, then I'd have the mass of the collection of them. But it's not very good for finding individual masses. But since we're going to be dealing with very large numbers of atoms, then this is fine. We're going to be able to use these. So remember, likewise, hydrogen is 1.01 AMU. So if we look on the periodic table, this is the number in that block for each element. Now imagine I wanted to know the average mass of a molecule of water, right? So water has the formula H2O. So a single molecule is made up of 2 hydrogen atoms and 1 oxygen atom. So what I can do is I can just add up the masses, 1.01 AMU plus 1.01 AMU plus 16 AMU for oxygen, which gives me 18.02 AMUs. So that is the average mass of a molecule of water. So that is we call this the molecular or the formula mass. Molecular mass, you can only really use that term when referring to covalent compounds, because ionic compounds don't occur as molecules. But we can do the same thing with an ionic compound. So when I do an ionic compound, like, say, sodium sulfide, Na2S, right? I'm finding the mass of just the formula of 2 sodium ions and 1 sulfur ion. So there isn't an appreciable difference. Ions don't weigh any more or less than their constituent atoms, or than their parent atoms. So what I'm going to do is I'm going to add these up. And so I would take, what's the mass of sodium? Looks like 22.99 AMU plus 22.9, oops, extra period there, 22.99 AMU plus 32.07 AMU, and I get 78.05 AMU. Okay, there we go. And so that's my formula mass for sodium sulfide. Now, one quick thing. There's an easier way to do these, actually. Instead of adding each one up, let's say I had something more complicated, like C6H12O6, right? Well, what I can do, instead of taking the mass of carbon plus itself each time, I can just take 6 times 12.01 AMU plus 12 times 1.01, pretty messy plus sign, AMU plus 6 times 16 AMU equals, this equals 180.12 AMU. So, one thing is we've had problems with significant figures here. Whenever you have multiplication and then addition, there can be issues with significant figures. So what we're going to do this time is it's easier and actually more accurate. Instead of trying to do the multiplications and then the additions, just treat it as though it's a pure addition problem, because really we could view it that way. I could take 12.01 plus 12.01 plus 12.01 and make it pure addition. So really just look at your number of decimal places, and that's how you're going to do the significant figures. Okay, so this average is called formula weight or molecular weight for molecular compounds. So we'll just do, actually, let's just do, I want you to try these, and then I'll do these and show you. So pause it and try these 3. Just calculate the formula weights or formula masses, and I will calculate this. Okay, so water we already did. 1.01 AMU times 2 plus 16 AMU equals 18.02 AMU. Iron hydroxide. So we have to take the mass of iron, which is, sorry, I'm having to look it up, 55.85 AMU, plus 2 times the mass of oxygen, plus 2 times the mass of hydrogen. And that's going to equal I don't know what the hell that was, man. I'm sorry.